Hello, everyone. We are the next 100. We are a part of the 100 Girls in Generative AI. Girls in India who are navigating the workforce, who are trying to build their career in AI. This is the best place for you to gain insights from industry experts, take charge of what is the new development in AI, and come innovate, build, and tinker with us. So for this particular program, the next 100, which will be our segue to how we select the girls for our 2025 cohort, we bring to you industry leaders right from the epicenter of AI, which is the Silicon Valley. And we are today very humbled and honored to have a distinguished engineer, Akshay Bahadur, from Yahoo. He's not only a prolific trailblazer in his field, he's also, done vast variety of programs for women's benefits, for the speech and audio therapy for the destitute in India. He's also done brilliant work with, the Google Scholars, and also a graduate of Carnegie Mellon. There's a long list of accolades that I would actually like to address. So we do full justice to all of the hard work that Akshay has put in. So here we go. As I just pull that up, please be patient. Um, okay. So love to emphasize that, Akshay's interest in computer science actually sparked by working on a women's safety application. So no, it was not just working on women's safety, but the interest in computer science actually sparked through this. And he was, increasingly tackling social issues through this particular technology. And he was currently working at that point of time with Google to make the Indian Sign Language Recognition System. He's also one out of the 8 Google developer expert in machine learning from India who belongs to the 150-member worldwide team for Intel Software Innovator Program. Also, it's incredible to see that someone so prolific has already delivered 50 plus keynote sessions and demonstrations of his projects globally. Also, his area of expertise is in information retrieval systems, prompt ranking, real-time data platforms, computer vision, natural language understanding, and big data systems. And just to wrap it up with his mighty achievements, here we are. He's invited by Google to present his Indian Sign Language solution right at the headquarters in California. He received the most influential young data scientist, why are we not surprised, for 2019. He also had the tutorial acceptance at the IEEE Winter Conference on Applications for Computer Vision. And he there presented the minimizing CPU utilization for deep networks. He was also a delegate at the 2020 Harvard College Conference in Cambridge, Massachusetts. Also, I swear, like, I'm going to finish it before the session ends. But he also contributed to Google's open source project, QuickDraw, and NVIDIA's open source project. We want to know how many stocks are in his portfolio. And last but not the least, he was offered an opportunity to work with the Google TensorFlow team at the TensorFlow Roadshow. So there are, I think, a bundle of resources and speaking experience that we will publish with this particular session. And it's our incredible honor to have Akshay. Akshay, over to you. A warm welcome, and we would love to hear from you on how you feel about being here with 100 Girls in Generative AI.
Thank you so much, guys. I think that was a great introduction. I'm actually feeling really honored to be on the stage. I'm going to assume that throughout this session, you guys will learn something from me, and then I'm going to learn a lot from you guys. All the achievements that Priyanka talked about, I think those are something that uh, I mean, I think I just got lucky. I was just at the right place at the right time. So I'm here to help you guys be in that same situation. So I believe if I could do something like that, then anybody could do it. So I'm hoping and rooting that you guys who are listening to this session will, be somewhere along the same journey, and then hopefully both of us can share this same stage at some point.
Amen to that. Definitely, there are some trailblazers right here in the group. We will get some time to get to the projects also. So, Akshay, um, having this spark in you, trying to identify it and actually putting action into place. How did find out that computer science was your ikigai? And this is the kind of, journey you have to pursue. The only reason I ask that is because the 17 to 21-year-old we work with, they're
Hmm.
always asking us, like, do we go to masters? Do we do, startup in India? Do we go to the next job? So we're trying to give them more clarity and direction in this perspective. So over to you.
I think that's a great question. So, from my perspective, I feel that I was a bit late because I went to a tier two, tier three college in India for my undergrad. So, I was never really serious, to be honest. I took computer science, but I was not interested in computer science. I just wanted to see what the hype was all about. I think after I did my undergrad, I graduated from my college in Pune in 2017. Is that when I actually thought that, okay, let me now put in the effort. So I think people who are listening to this particular podcast, I think you are on time. Like 17 to 21 is the perfect demographic to start if you want to get into this field. I was a bit late. I started at around 2022, 23. So a bit late to the party, but nevertheless, for me, for my specific use case, AI. So I did not pick AI or ML directly from the start. After my undergrad, I think I started working as a Java developer at an organization in Pune itself. It was fun time. Like I had a lot of fun. I made some really good connections there. But at the same time, I felt that this is not my calling. I would like to explore more. So around that time, blockchain was getting really popular. So they had this whole crypto boom that happened with Bitcoins. And then there was this research paper on how Bitcoin works by Satoshi Nakamoto. So I read that paper. We did a little bit, me and my friends, we did a little bit on blockchain. Then I also was interested in IoTs. So I did a little bit of IoT as well. Couple of my friends from my undergrad were majoring in electronics, so they already had experience. So I learned something from them. Um, and then I started IoT. We did a few of the projects in IoT. But then I stumbled upon machine learning, and I felt that machine learning was the perfect sort of a mixture or a blend for me of both maths and computer science. So I've never been a great math student, but I've always loved mathematics. Like that's the least amount of effort that I put into any subject. So when I felt that when I saw this whole amalgamation of CS and ML, I thought that this is a game changer specifically for me. And at the same point, um, internet was getting popular in India. Like we had Geo coming along. Geo was very popular in 2016 when they were giving free internet. So I was one of the first customers to get free internet for multiple months and years. So then, because of this whole abundance of internet, I picked up some courses online, and I think the one course that I would highly recommend is again it's a bit old course. I think it started in 2010. Is the machine learning course by Andrew Ang from Stanford University.
They
He's
actually
co-
updated it. They actually updated
to
it, Akshay.
Oh, okay, that's perfect. So I might do it once again. So I did when I did it, it was in MATLAB, and I have never like I have done only couple of months of MATLAB in my undergrad. But then he explained, I think the professor Andrew Wang explained the entire process of how how a model works, what exactly is a model, and the maths behind it. And I think I spent like it was a 3.5 months course, but then you have to religiously follow it. So I did that. Like I did my hard work. I think for at least 1 year, every day after my office, I used to come back and study for 2 to 3 hours. And then even in the morning when I was going to my office, I used to revise whatever I studied the day before. So 1 year, I think I just spent on learning these new technologies and these new courses. So 1 year was just putting in the effort without knowing that whether it will pay off or not. But then you need to have that motivation. So if you have that motivation of getting into this field and doing something, relevant, you have to put in the effort, you have to do the hard work.
This is fantastic to know. The variety of journey that you have taken from a tier 2, tier 3 college, I would never have guessed. To which is the most inspiring thing. You have so many accomplishments, but I want the students to hear and know that the college is not a barrier to your success. Lot of students come to me thinking if you don't get into IITs, like your career is done, and they get into depression. So please do not do that. I myself, again, my startup got picked up by an Ivy League. I didn't go to an Ivy League. So again, Akshay is the best example here on how you build your career trajectory. While saying that, the journey from you just chasing your curiosity, Akshay, from that Satoshi Nakamoto's paper to going ahead with, leveraging that free internet in India and then building systems, that proves a powerful testament of what, if somebody is really passionate about a technology, can go to several lengths to. So kudos to you. We are hoping you come back to blockchain soon, because the winner from our cohort, it's Dhan Kanya. So they have built a voice-enabled automation engine for 25 million girls who are dropping out of schools. So the roadmap is to take it on blockchain. We've applied to certain blockchain grants also, so that we have some secure authentication mechanisms. But so happy to know you have this connection with you. While we are exploring your journey, wanted to understand, you rightly pointed out that, hey, look, machine learning, you started with this basic course from Andrew NG. Did it then evolve into exploration of CNN, NLP, and then now LLMs? Like, how was that transition?
Yes. So initially, I took this one course that I talked about for machine learning. That was a basic machine learning course. Then they also offer some online courses on deep learning. So I thought that okay, naturally the next trajectory for me is to learn deep learning that was getting popular at that time. So deep learning was not really popular, at least in India. It was getting popular. So they also offer a specialization in deep learning where they teach you right from the basics of basic machine, simple neural networks to some deep networks to CNNs, and then I think they finally end at RNNs around that time. So that was also around 4 to 5 month course, which you can get on Coursera. I believe that they might have updated it as well. So natural progression was to go to deep learning, and I think deep learning is where things started to get a lot more interesting because usually in like traditional machine learning, you can only work with specific number of features, and then you have to also understand the features up to a certain extent to perform some transformations on those and do some feature engineering. But with deep learning, things get slightly more complicated. But at the same time, the network really helps because the network grows in itself, and you have to do more of the effort in building the network than to actually do the feature engineering because the network takes care of it all along. And then you now have capabilities of doing some multimodal stuff. So instead of just working with numbers, you can transform images to pixel values and then work with those. You can transform text to some embeddings, some number values, and then work with those as well. So it kind of opened the whole gateway towards whole multimodal algorithm and multimodal learning. I think that was really interesting for me. And again, like up until CNN was really interesting for me because specifically storing and working with images has been pretty I mean, I was pretty curious in that area, and this stemmed from my stint at my undergrad where I studied image processing. So image processing, I did some basic image processing at my undergrad. It was a 2 3 month effort, and I understood, how images work. And then when I learned machine learning and deep learning, and when I learned about CNN, so then I started connecting these two dots. So I had done image processing in the past, and then I was doing image processing via CNN. So I could use concepts that I've learned about filtering, transformations of images directly to the CNN network, and then I could get good results. So
Yeah.
it was more of an explorative journey, and that's why I always try to emphasize on the fact that any sort of knowledge that you get, whether it's deep learning or not, whether it's ML or not, is going to be helpful in the future. Because if I had not taken that course, or if I had not taken that image processing interest area and spent some time on it, I would never have been able to implement those techniques in my deep learning network. And this really helped me because firstly, let's say I was building some applications, and then I think Priyanka also mentioned that at the start that I've contributed to certain open source projects. So because I knew image processing as well as deep learning, I was able to connect those two dots and build applications that were pretty unique. So for specifically, I want to talk about just one small project. So for NVIDIA, I worked on behavioral cloning. So behavioral cloning is around that time, Autopilot or NVIDIA's Autopilot was getting popular, and basically the idea was for the whole autonomous vehicle driving. It was pretty new at that time. And then this idea or this paper that NVIDIA published, basically given the image of a road, you had to predict the steering angle. So they gave a data set of the images, and they gave you that for this particular image, this is the steering angle. Now the issue with this at that time was a lot of people did not have GPUs or heavy CPUs, and Google Colab was not available at that time. So every machine learning development had to be done on their own but personal computer. So now again, I did not have a GPU, so I took some image processing knowledge, and I filtered out that image. So the image was a colored image. I converted it into a black and white, and then did some transformations to only focus on the road. And I knew that the road was towards the lower half of the image. So instead of working with the entire image, I was only working with a part of the image, and then still being able to give good results. So I think that was really interesting. So it's all about connecting the dots. And then with CNNs, it became really interesting for me. And I think a whole new area of multimodal sort of computing opened up with deep networks, specifically with CNNs and RNNs.
Ashutosh, I was just, passing the baton to you. Since we're getting a little bit more into the technical aspects, if there was some hurdles related to, how you're building these systems, maybe we should touch upon those challenges so the students can gain benefit.
Perfect, Priyanka. Yeah. Um, so there's a lot of things to unpack here, right? So I have like a couple of questions for Akshay. So you started from image processing, right? And then you got like ideas on how to actually work with images, and then you kind of transferred those things to CNN. So, is there anything specific where you found that, CNNs, specifically in CNNs when they came out? I mean, they came out a long time ago, but when you started using them, right? What were the things that were like you felt like, okay, this is really different from what I have seen before, and I need to, do something else with this particular technology.
I think specifically for me, in order to understand how images are being processed in general in computers, because computers cannot understand images, they have to read numbers, right? So converting images to pixels and then retaining the information was something that was fascinating for me. Having said that, when I took some courses, of course, I did my own research online, and then I found out that CNNs were really popular. Like they're not popular, but the idea exists throughout. I think in the 90s as well. So 1990s was when the first autonomous vehicle was the idea was actually conceived, and I think the person who developed CNN networks, I think he's the head of AI at Apple right now. I don't know the name exactly.
I think he's at
Uh,
Meta, Jan
oh yeah,
LeCun.
yes, correct, correct. Meta. He was, I think he was at Apple. Then he joined Meta. And a funny story. One of my friends who was at New York University met him. He was working as a librarian. As a student, you can volunteer and get some money as a student. And then
Wow.
he had no idea who Jan LeCun was. And then I think eventually somebody else told him that he's the. I think he was also a professor at NYU at that time. But yeah, but funny story. But yeah, I think so. So it got really popular around 2000s when the whole deep learning framework started coming into picture, and just the idea of having this model that can distinguish between images. And around that time, ML algorithms were not really intelligent. So I think the best ones were doing categorization between different images. I think there were different data sets. I can't recall the name, but there were like basically images of certain animals which can be distinguished around 100 different classes or 100
Mhm.
different types of species. And then the best algorithm was only able to do it 93% of the time, and humans
Right.
can do it 100% of the time.
And
So
even those data sets were like the images were like 64 by 64,
64,
very,
correct, right? So
yeah, very
pixelated
pixelated.
values, you had no idea what was going on. But then, yeah, as already mentioned, so it was interesting. But then, what I really wanted to do was actually build solutions that were end to end and can actually solve a problem. And then I started posting them on GitHub. So I had no idea what I was doing. I just wanted to learn. And these projects that I did were mostly in computer vision because I think that was interesting to me at that time. And then I started posting them on GitHub just for fun, and because those were mostly kind of like test codes for my own learning. Let's say if I learned CNNs in this week and I learned about, let's say, activation functions, I would use an activation functions, develop a small model just for my own learning, and then post it on GitHub. And then I started posting it also on LinkedIn, and then I realized that a lot of people were also in the same boat as me, who were trying to crack into this field, and they started liking my work, and I also started contributing more, and I started also taking inspiration from other people. So I think it was also a collaborative effort. And if you don't know more, I am just going to post my link to my portfolio website and my GitHub in the channel itself, so you guys can have a look at that as well. So you in my GitHub you'll find all the projects that I've done over the past 7-8 years ago, and then you will also find some recent projects that I've been doing a couple of weeks back. So yeah, you will have all the information there.
Perfect, perfect. Yeah, that's really great. Thanks a lot for sharing that, Akshay. So, all right. I mean, so that was a great great journey from like how CNNs are like used and how they came to be. Um, so my question is kind of like your transition from, I mean, not really transition, but focus, like keep changing focus, right? So,
Hmm.
right now, what is your main focus area?
So up until now, so this was mostly done. My journey up until that point when I was working on CNN was mostly explorative because I wanted to do a breadth-wide search of all the areas I can, work at and look at. And I hadn't really explored NLP up until that point. Computer vision was really interesting, and I thought that this is something that is where I can actually go ahead and work at. But then I started exploring NLP, and I felt that NLP had a lot more use cases to be addressed, and I felt that I can use some information from my image processing or deep learning background to use it. And then when I started actually working in machine learning in my office, um, that is when I came across information retrieval, which is basically how to build search engines, how does ranking work, how does product recommendation work, and all of it uses NLP and images both. And that's when I started realizing that okay, this is an area that is pretty interesting. It's a very niche area within machine learning and deep learning. where I can use my own knowledge and build algorithms. Now again, I'm still I feel that I'm still pretty early, and as engineers, you can always adapt to new changes. But then for now, I have been focusing a lot on information retrieval, which is how I did my master's as well. So in my master's, I took courses in information retrieval, and then right now at Yahoo, I'm again working on recommendations and LLMs.
Okay, interesting. So, yeah, lots of interesting things there, right? So when you found out about this, the information retrieval kind of like subdomain, um, then you had to go into again. I think there were some things in the deep learning course, like related to sequence modeling and things like that.
Yeah.
But when coming to information retrieval specifically, when you combine both of the images and the text, right, both of the concepts are like together working here. What did your like learning curve look like, or what did you think at this moment, and what did you actually do to kind of go over
I
that?
think so. That's an interesting thing in AI in general is that the field is evolving such a high rate that even though you might be a master at a specific subcategory, you have to keep on learning. So I think that mentality has helped me in the past, and not just then, even now, because up until last year, LLMs were not popular. So even though the sequence modeling and traditional recommendation and traditional ML algorithms would have worked the best, but now because of LLMs, I again had to go back, study how LLMs work, study the basics of it, and then understanding on how exactly can we use that to build our systems. So again, in any when you are switching something or when you are staying in this field, which is continuously evolving, you have to if you have to be at the top, then you have to continue studying and continue putting in the effort to do research, and maybe even listen to multiple podcasts that are happening about the recent developments. I think that keep. So when I switched to information retrieval, again, luckily I had a really good mentor at that time, my manager, and he helped me, kind of guided me, and held my hand while crossing that path. But then at the same time, I had to put in the effort because I was delving into this new area that I've never experienced before. But then luckily, I had some good resources available with me, and of course, I had to put in the effort. And then I liked that field so much that I started doing a lot more research on my own. Um, but that's even true even now because I think couple of months back we started an LLM initiative at our workplace, and for that, because nobody knows about LLM, so it's ground zero for everyone. Like it's level zero for everyone. So you have to start again from that. So luckily, because I had this whole concept of adapting and changing my skill set and learning new skills at that time, I was able to get on top of the LLM methodology at that time and get some good results. And then also because of the experience that you have learned about ML, DL, CNNs, you can use that knowledge and how ML uses transfer learning. You can do the same when you are learning something new. You can transfer knowledge from your previous experience onto this new one and get better and faster results.
Right. I love that analogy, how transfer learning works in ML as well as in real life. So, Priyanka, before I get back to you, just one last question, and I'll be a little selfish here. I'm working as like a researcher in my university, right? And or I was working as a researcher in my university until I graduated, and now I'm kind of like transitioning to the industry, right? And I believe like there will be hundreds, if not like thousands of students like me who are going, transitioning from university
Mm.
to the industry. And since you have already been in industry for some time, right? Especially in this domain, um, how does this kind of like open-ended research, like, because in companies most of these uh, problem statements are like open-ended, right?
Yeah.
And you don't really know if there is something actually going to come out of it or not,
Mm.
and you're still working on it. So how does that look like in the industry? Or maybe like specifically if you want to talk about your company, that's also good as well.
Yeah. Oh, that's a great question. So this is something that I realized while both researching and working in companies is that the the metric changes. So, for example, let's say when you're building a search engine, let's say, for example, in academic setting, you would want to maximize relevance. You would want to give relevant documents to the users when users some searching for something. You are optimizing for the relevance, but in the industry, you are optimizing for revenue. So you may or may not want to give the best results, but then you would want to give the result that maximizes the chance of the user to actually purchase the product, or
Right.
actually, let's say if it's a search engine, to actually click on the website and then look at the ads, and that's how Google or Yahoo or any of the search engines make money. So that whole metric changes. So if you want to, when you're transitioning, this whole idea of, different metrics, which may or may not make sense. But then, of course, at the end of the day, if you are working for a company and the company wants to make money, you have to, respect that. But if you are in an academic setting, you are working to provide state-of-the-art results, then you have to work with a different goal in mind. So I think
Right.
that change in mindset is important. Secondly, talking about secondly, talking about the different open-endedness of questions, definitely. So, with something that I've realized in different organizations is that organizations they have specific criterias to evaluate the model. So the first one is, it might not be the accuracy, it might be the latency. So even in some companies, they use very simple models like, let's say, GBM models or random forest models, which are, pretty old, but then they do the job for them, and also they have good latencies. So if you put in a deep learning based network, a transformer based network, but it takes in a lot of time to give the inferences, then it might not be useful for the users, because they don't want to wait for, let's say, a couple of seconds to get their results back. So that is something that was also new to me when I realized that, okay, perhaps a simple solution can also be very elegant. And this whole methodology comes from a very famous sort of a principle called as Occam's razor, which means the simplest solution is almost often the best solution.
Right.
So that I never saw that in an academic setting, but then at a workplace I saw that in action, and it worked. So that whole openness definitely is something that people, would like to solve. But then at the same time, in an industry or when you're working at some place, you would want to at least build your system to a certain maturity and then leave it as is, and then hope that in the future, if things go back or if things go worse, or if you want to come and improve it, you can then come and improve it. So you need to build systems in such a way that you can always iterate back and then solve that problem at a later stage. But then when you are at least deploying it to production, you need to at least get some sort of a metric and some sort of a level of accuracy, or conversion rate, and then you can leave that model, and then hopefully when you come back, you can then improve iteratively over it.
Right. Okay. So like start from somewhere and then kind of like iterate towards what
Yeah,
feels like the best for that particular industry.
correct.
Okay. Interesting. So I have a lot of questions here, but Priyanka, I'm just going to give it back to you because I can just spend this entire time. Uh,
Yes.
so yeah.
Yeah, I have notes enough for the entire weekend that I need to go look back and like, okay, Akshay has actually, probably done a inference endpoint introspection here and whatnot, so I can prepare my cohort well for the next year. But Akshay, over to you. Just final question from me because I'd love for the students to come and speak. Um, we are in this age of advancements, but the biggest barrier that we're seeing is acquiring the infrastructure to build AI. Like, how does one, just theory knowledge, just with those courses, we wouldn't be able to go ahead. So, how do we build systems when the barrier to entry itself is probably acquiring like a Intel RK 770, right? Like, or some kind of
Yeah.
GPUs. How do we come about that? Yeah, and then I'll ask just the final question on LLMs. Um, just with the kind of big data sets that we're dealing with, there's a lot
Hmm.
of risk of hallucinations. Do you
Hmm.
prefer working with SLMs versus LLMs? And do you recommend that? So, we'll just go on to infrastructure and then SLM versus LLM.
Okay, definitely. So, good question on infrastructure. I think that's mostly because how fast this field has evolved. So, I remember when I started working on these simple problems, right? I did not have a GPU, and but if the data set was small enough, I could do it on my CPU. But then Google Colab came into picture. So, if you are using Google Colab, you can get some sort of a level of GPU, some RAM of GPU for free. You can use that for your development. But then having said that, I think over the past 2 to 3 years, I've seen a lot of rise in the amount of data that is available, plus these large language models. And I think that has affected the democratization of machine learning. I think that was pretty popular in 2018-19, where people wanted everyone to be able to build a machine learning model on their own. But then with LLMs, even big companies cannot develop their own GPT-3 or GPT-4 just because the cost for developing such a huge system is going to take around maybe millions of dollars of money, and plus it's going to leave a large enough carbon footprint, right? So you would not want to do that. So having said that, I think you need to find that balance. So there are techniques available on the internet where people have, talked about certain frameworks or certain sort of distributed frameworks or certain quantization quantization frameworks where you can break down your model into smaller chunks and then train them, or break down the data into smaller chunks and then train them. But then having said that, of course, if you want to build state-of-the-art algorithms, you have to put in the effort, and not the effort, but you have to put in the investment. So either you can use platforms like AWS, or runpod.io, or even Google Colab. You can get the pro version of Google Colab GCP to get the GPU needed for training. But then having said that, if you're a starter, I will highly recommend that you use the basic Google Colab free version, and you will at least have some bandwidth of data to work with. And then if you feel that you actually need a bigger system, then you can go ahead and maybe purchase some of these products. But also keep in mind that the purchase also, you have to calculate how much time it takes and how much money will you be spending, because without calculation you might end up spending more than what is required. Now coming to the second question on LLMs versus SLMs, I think it all depends on your particular use cases, right? So you might not want to use OpenAI API. You can use a simpler or a smaller model like I think Microsoft has a Phi model which is around, I think, 1.2 billion parameters. That's still heavier. Or you can go for Llama 3, Llama 2, or Mistral in that case, which has 7 billion parameters, which is still good. And I think you can at least train the smaller models on a free Google Colab version and then get results. And I know this because I've trained like smaller models. I've trained like 70 million. There's I think the smallest one, which is okay, is called as Pythia, Pythia, Pythia. I think it has the company, and they have released a 70 million parameter model, which is easier. It can be easily trained on a Google Colab notebook for free. And then of course you can iterate and see which one works the best for you. So I think it depends on the use case, LLMs versus SLMs. LLMs have a great wide knowledge. So if you're working on building a chatbot, which the people can ask multiple questions, maybe even maths question, reasoning question, then you would want to use an LLM. But let's say if it's a very specific use case, you only want to build like a categorization, something between, categorize this piece of text into this to this, then you can use a small language model and still get good results, and maybe fine tune it for your particular use case and get good results.
Very incredible insights. We've actually noted down like what is within the 5 billion parameter for the small data sets. We will use those within Microsoft Mistral. I think Meta is having a release on July 23rd. It's going to go down in history to be the day of open source. So really looking for that, forward to that. And first time I heard about Pythia also, this is within the 70 million model parameter
Yeah.
range, right? So definitely we're going to take note of this. And students, if you're listening, Abacus AI also is like a good playground within budget. So, highly recommend you to that also. So when Akshay's post goes out, you will find all these resources logged into that post. So without any further ado, we know all of you are like super excited to speak. I would actually want to first invite Gopika. I'm just looking here because this Gopika, if you could just give a introduction to the child malnutrition GPT you've built. This is one of the most critical projects coming out of the cohort because we actually teamed up with one of the top pediatric surgeons in India, Dr. Tanmay Motiwala. Huge regards to him. Because for the millions of children that we have in India, the children to doctor ratio, pediatric surgeon ratio is like 1 is to 1300. And therefore, technically, it's like, for there's only 1300 pediatric surgeons within the country. So if they want to at least do preventative measures and diagnostics, they would need some kind of tool just to assess if the child, is doing certain checks within the age, weight, height, and gender, metrics. So, Gopika, maybe we do a quick introduction of your tool, and if you had any questions, and then we'll open it up to Chandrakala also, and then everybody can like chime in. So, Gopika, are you with us? Gopika usually has system issues. Gopika, you can type your question also if that's okay, because this is a solid golden chance for us to improve our solution. Okay, something happened there. Chandrakala, over to you. Are you with us?
Yes, ma'am.
Okay,
Thank you.
great. Chandrakala, did you want to give like a brief of your project and anything that you always bombard us with questions like, ma'am, should I build on this particular F foundation model? Ma'am, should I build on AWS related API endpoints, right? So this is your chance now. Go ahead.
Yeah, thank you so much.
Yeah.
So, hi everyone. So, my name is Chandrakala. So, I had built my own GPT by taking inspiration from Priyanka ma'am motivation and some of the classes from Anjali ma'am. Previous, I don't know how like a GPT is working, what are the coding for that and ML everything. So after joining only this course, I learned what is mean by RAG, like how the GPT process will be happen in the mission. Everything, this motivation given by Priyanka ma'am. Thanks, wonderful. So, and Sandeep sir helped me in the API key, how the open AI, it will ask like a cast. So, everything I got support from the Priyanka ma'am. So, finally, I built my own GPT. It's called skill recommendation. Basically, what it will do means so whatever the students or anyone will ask based on their hobbies and interest, it will give the proper recommendation. For example, it will work both as well non-technical and technical as well as so. For example, non-technical wise, I will ask like my GPT. So I'm good at skill drawing, painting. So what are the features, career path for me? Like I choose drawing, right? So what are the career paths and guidance? What are the having that based on that career path, it will recommend. And technical side also, for example, if I have interest on software skills like full stack web development, so what are the ways to can begin and where I need to begin, like a foundation of fundamentals to how I can go one by one. It will give the proper recommendation for to reach my career
I
goal.
think I think that's very interesting. I think that I did something similar for my grad school, but at that time we did not have LLM, so we
Okay.
used like simple text matching to recommend courses based on the skills that you would like. But then with, of course, with LLMs, what you have done, Chandrakala, soon it sounds very interesting, and probably I will take some inspiration from you and probably implement that to the course course recommender that I built at my grad school. So I think that's very interesting, and I wish you all the best, and I hope that
Yeah,
you
thank
improve
you,
it and
thank
maybe
you.
build on something, build something that's even better, and then yeah, I think I'm really glad that you shared your work with me.
Yeah, thank you, Akshay. I have one more question after this
Sure.
introduction. Yeah, I will ask one question I
Okay.
have.
Okay.
So, and one more thing, I built a low code, no code, that app called as a resume synthesizer. Basically, this one also what it will do means when we are uploading our resumes. So, which areas it's not good. If we are asking
Okay.
where I can enhance my resumes, it will suggest the these main areas like, for example, educations and certifications and profile. Wherever we have to enhance it, it will show properly that lack of uh, improper of resume. So
Okay.
based on that, we can build that areas and enhance it.
Very
So this
interesting.
I
I
did.
I think both of these are highly relevant, and these are the projects that I like that can actually provide value.
Okay.
And so good luck to you. And then if you can share your GitHub, if it's on open source, I would love to have a look at the source code as well. But good luck, and then also all the very best for new future projects, because I feel that you will build more such interesting and nice projects. So good luck to you, Chandrakala.
Yeah, thank you, Akshay. So, yeah, I have a question like, for example, I
Chandrakala,
have,
dear, hello. So
yes, ma'am.
sorry. We'll have to give equal time to everyone, okay? So,
Oh, sure, ma'am,
yeah,
sorry.
Akshay sir is going to be there with us. Your GitHub. He
Yeah,
will go through and see if we need. We have our meeting ending in 10 minutes, okay? So
sure, ma'am,
let's
sure.
see if Suhana, who's built the finance GPT along with the team. Again, Gopika, your child malnutrition GPT, if there's questions on migrating the solution or any kind of inference cost training, you can all ask now. Like make it very detailed because all other things we would definitely have answers for. Okay. I mean on the net. So Gopika, Madhavi Lata, please come forward. We have like 10 minutes.
Yeah,
And in the
well,
mean,
am I audible, ma'am?
yeah,
Yes, yes, you're audible. Sorry, was it Akshay? Yeah. One
yeah,
more.
yeah.
Yeah. Go ahead, Akshay. Yeah.
No, I think Gopika asked this question. And Chandrakala, in the meantime, you can probably just type
Sure.
your question in the chat. I'll
Yeah.
probably try to answer it before the question before the meeting ends. And Gopika, you can go ahead.
Oh, well, uh, yes, it's so great to be, to be here, like attending this meet. And I have actually need few tips because, especially up to now, I have been into some programming type of environment. I want to change my career into AI completely because, yeah, on one part of time I used to hate AI, but yeah, recently through Giga I was like immersed in AI field and I want to jump into that career. So for the beginners, mostly I too have some friends who want to change their career paths. So what is the roadmap you give us uh, as a beginners, uh, like us?
Got it. So, okay, so good question. So, I think it keeps on changing, but then the main idea is that you need to get your basics right. So, for example, let's say if you want to really get into machine learning and deep learning and understand the workings of it, then you need to work on, starting with these online courses that I mentioned on deeplearning.ai, where you can go ahead and understand how model works. Now, if you want to probably skip that part and move towards how applied ML works, that's also an option. So, for example, let's say if you want to learn how to use the model, then there are courses available for that. I will highly recommend a deep learning visiting deeplearning.ai website, and then there is also available courses like fast.ai where you can just work on how to use applied AI for that. So courses are available. You just have to put in the effort, and then build projects, and then in the interview, you have to explain that even though you don't probably have an academic background in machine learning, but then through your projects and through your online courses, you have developed enough understanding to provide value. So yeah, I think over to the next question. We have 7 minutes left.
Gopika, did you want to understand how students like you who are,
Yes.
say, either in Java, C Sharp, like you're currently doing the regular coding, how you want to jump to it, right? That was the second part.
So to answer the
Yeah,
second
yes,
part,
it's
yeah, so don't worry
clear.
about it because I also come from a Java background. So I have a lot of interest in Java, and I have been learning Java for a long time. But then making that transition is pretty simple. It is just that you have to prove your capabilities as a machine learning developer, because at the end of the day, you are an engineer. You are you don't need to have Python skills. You don't need to have Java skills. You just need to be able to solve machine learning problems, right? So doesn't matter if you use Java, Python, or if you have that understanding, you can do it in any language. However, of course, learning Python definitely helps because all the other, like, it's actually using machine learning and developing systems in Python is easier because everything else exists in Python using libraries, so you don't have to do a lot of hard work. So I will recommend learning Python, and then learning how these basic libraries work, like scikit-learn, PyTorch, Keras, as well. So if you know these simple libraries, and if you have built good projects, and you know the understand how these different algorithms work, you will be able to get into a good role, and then you can use knowledge from your Java skills. So for example, I use Java. I had knowledge of object-oriented programming. I used it in my ML solutions while writing in Python. I still use object-oriented, and that helped my code become more scalable, and it helped the whole that whole pipeline. So yeah.
Great. Thanks so much, Gopika, for that question. Madhavi, we take your question and then we'll have to wrap up in minutes. Madhavi, over to you. Yeah.
Uh, Thank you, Priyanka ma'am. And hi, Akshay sir. So glad to meet you. So my question is like currently I'm doing like software developer. So if I want to create any project, so
Mhm.
what are all the tech stacks that I need to learn more, including AI? Like any suggestions for me?
Okay, so if you want to be an end-to-end, let's say ML engineer, sort of, so there are different areas in ML as well. So there's a researcher part where you work only on state-of-the-art algorithms, right? Where in that you need to understand how the math works and how different algorithms work in PyTorch or in any deep learning framework. So that's one case. I'm not interested in that. And then there is something called as applied research or ML research or ML engineer, where you can use these state-of-the-art algorithms to actually be able to scale and build systems for your organization or for your work. And that is where I feel is the best area for me, because it means that I can work with software engineering as well as with deep learning and machine learning. So for that, you definitely need to be a good engineer. So understand how algorithms work in general for software engineering and for deep learning. Also, if you have a little bit of understanding of mathematics, that's also helpful. And then be able to build these data pipelines, because you need to do feature engineering as well. So if you have good understanding of data pipelining, maybe things like Spark, Hadoop, that helps. And then finally, when you're actually building models, that is when you will need to learn these libraries like scikit-learn, and Keras or PyTorch, or even up until a certain extent, if you can use LangChain, if you are directly calling OpenAI, so you can use LangChain for that. And then finally, for inference, you need to understand different frameworks. How can you use to deploy your model? For that, probably Docker is good. I've used Docker in the past. And then if you want to use AWS or GCP, that's your choice. So you need to understand that as well. So a couple of points, but then if you break it down and slowly work towards it, you will be a master in this in no time.
Yes, sir. It's really helpful. Thank you.
All right. Thank you, guys. Yeah, I
Right.
think almost out of time, Priyanka.
Yeah, almost out of time. But those were our shining stars. We will send you the GitHub repo for of all the projects, Akshay. But this was a you set the benchmark so high of what an engineer can do, and that we're all like, we will follow. It's a great, session to have with you. So yeah, Ashutosh, if you had any closing thoughts, will
Um, I mean, not really nothing. I mean, I have a question. I have a lot of question actually to ask,
we are
but
awestruck at the moment.
yeah,
Yeah.
yeah, that's all right. I mean, we talked a lot of great stuff today. If someone actually really wants to become a machine learning engineer, all the resources are there shared in the chat. So
Right in Akshay's portfolio. Don't need to
yes.
go anywhere on the internet. You have
Yeah.
the entire transition as well. So yeah, one less than 1 minute, Akshay would love to hear you and close it.
I think so. Thank you so much for this opportunity. I had a great time and learning from you guys as well. I would love to hear your journey even more. Love to look at the next cohort, what they are doing. And then good luck to everyone. And then I had a great time. And hopefully we can do this again sometime. And yeah, I can't wait to meet the next cohort and then be, of course, enamored by what you guys are working on. So good luck to you guys and hopefully we'll meet soon.
Fantastic, Akshay. Last but not the least, where are you from? Which part of India?
I'm from Uttar Pradesh.
Uttar Pradesh. Okay.
Yeah,
If
I'm from
you
Allahabad. I've been staying in
Allahabad.
Mumbai for a while now. Right now, I'm in the US.
Oh, very cool. We